What if you could find some of the most critical security flaws in the software we all use, just by teaching a program to have a memory? Well, that's pretty much the core idea behind what we're digging into today, a seriously powerful technique called AFLNET. It's something we never really think about, but every single time you connect to a server, whether you're logging into a website or streaming a movie, your device is having a conversation with it. It's a back and forth, and just like a real conversation, what you say next totally depends on what was just said. So here's the big problem for security folks. How on earth do you automatically test that kind of conversation for security holes? Especially when a tiny bug might only pop up after a super specific long sequence of messages. It's like trying to find a needle in a haystack made of other needles.
Okay, so before we get to the really cool solution, we've got to wrap our heads around the problem itself. And it's got a name, the stateful server problem.
So what does stateful even mean? Well, it just means the server remembers stuff. A calculator is stateless. It doesn't care what you calculated 5 minutes ago. But a chess partner, oh, they are definitely stateful. Their next move is based on the entire history of the game. Servers are like that chess partner. Context is king. And hey, this isn't just some academic idea. This is a real-world headache. That quote you see, it's from an actual developer, basically tearing their hair out in a user group. They're saying, look, I need to test this whole sequence, this whole handshake, but my tools just can't do it. You can feel the frustration, right? So what was the old school way of tackling this? Well, people used a technique called fuzzing, which is basically just throwing tons of random data at a program to see what breaks. But the old methods had some, let's just say, pretty big blind spots. Okay, so you had two main camps. First, there's coverage-based fuzzing. This thing is fast, like ridiculously fast, but it's completely state-blind. The analogy of a blindfolded sprinter is perfect. All speed, no direction. It has no clue about the conversation's flow. Then you've got stateful blackbox fuzzing. This one's smarter. It gets the whole state thing. But its weakness? It relies on a manual for the protocol, and let's be real, those manuals are often outdated, incomplete, or just plain wrong. It's like an explorer with a ripped-up ancient map. Neither one is going to get the job done.
And this is where our hero enters the scene, AFLNET. It's a completely different, much smarter way to do things. It's built from the ground up to fix the problems of both the blindfolded runner and the lost explorer.
So what makes it so special? Well, AFLNet is the best of both worlds. It takes the lightning speed of the runner and combines it with the smarts of the explorer. But here's the absolute game changer. It doesn't need a map. Why? Because it draws its own map as it explores. It literally learns the rules just by listening. So here's how it pulls this off. It's pretty genius, actually. It starts with a recording of a normal, successful chat. Then it starts messing with it, mutating the messages. After each mutation, it listens carefully to the server's reply. If the reply is something new, something it's never heard before, it thinks, that's interesting, and saves that sequence to build on later. And the best part? No manual required. All right, so this whole learning thing sounds cool, but what does it actually look like in practice? Let's walk through it. It's this really elegant four-step loop that just keeps repeating. First, you listen. You just watch a normal conversation and map it out. Then you mutate. You start changing things up. And then, and this is the most important part, you learn. You see what the server says back, and you update your map. It just gets smarter and smarter with every single try. Okay, theory is great, but let's see this thing in action. We're going to use an example right from the research paper and watch AFLNet figure out an old-school file transfer protocol server all on its own. So at the very beginning, AFLNet is just a fly on the wall. It sees a user login, user foo, server says user okay. Then pass foo, server says logged in. Easy enough. So AFLNet draws its first little map. This is the correct way to have this conversation. But then the fun begins. AFLNet gets curious. It thinks, what if I change the password? So it tries passbar. And suddenly, the server sends back something brand new. Code 530, not logged in. And for AFLNet, that's like striking gold. It's just discovered a secret path that wasn't in the original script. So it immediately adds that new path to its map. The map is growing. Okay, this learning process is really clever, for sure. But does it actually work? Does it find bugs that matter? Oh yeah, the results are where this goes from a cool idea to an absolute monster of a bug hunting tool. I mean, just look at these numbers. They are wild. When they put AFLN up against other top-tier fuzzers on this light FTP server, it wasn't even a competition. It explored 121% more of the code's decision points. Let me say that again. It explored more than double the parts of the code. It was reaching places the other tools didn't even know existed.
But, exploring code is one thing. Finding actual real-world vulnerabilities? That's the whole point. And on this popular streaming server, Live 555, AFLNet hit the jackpot. It found 2 zero-day vulnerabilities. That's a bug that nobody knows about yet. And get this, one of them, CVE 2019-7314, was found only by AFLNet. The other tools were completely blind to it.
So you're probably wondering, okay, how bad were these bugs? Well, in the security world, they score these things on a scale from 0 to 10. And the bug that only AFLNet could find, it got a score of 9.8. That's not just high, that is critical. We're talking about as bad as it gets. This wasn't some tiny little bug. This was a catastrophic security hole in software that's running on millions of devices all over the world. Think IP cameras, video streamers, you name it.
So, why? What was AFLNet's secret weapon? How did it find the bug nobody else could see? The reason is just perfect. The bug was hiding in an undocumented shortcut in the server's conversation rules, a path that didn't exist in any of the official manuals. So, of course, the tools relying on those flawed maps, they never stood a chance.
And this is the mic drop moment. Get a load of this. This is a real comment left by a developer in the source code. They wrote, "This isn't legal, but some clients do this." They knew about the shortcut. They probably thought it was just a harmless little quirk. They had no idea it was a ticking time bomb. But AFLNet found it because it doesn't care about the official rules. It only cares about what the server actually does.
And that leaves us with this kind of unsettling question, doesn't it? Our whole digital world is supposed to run on these neat, orderly rules. But what we've just seen is that it's full of these secret backdoors and forgotten pathways. Tools like AFLNet are our best shot of finding them, but it really makes you wonder, how many more are still out there, hiding in plain sight in the software we use every single day?